The Pythagorean theorem describes a relationship between the lengths of the sides of a right triangle. Remember, a right triangle always has one angle that is exactly 90 degrees. The formula for the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the lengths of the two sides connected to the 90-degree angle, called legs, and c represents the length of the hypotenuse, which is the longest side of the right triangle not connected to the 90-degree angle. Let's see an example. If we have a triangle CAT with sides length 7, 24, and 25, we can determine whether or not this is a right triangle by plugging those numbers 7, 24, and 25 into the Pythagorean theorem. If CAT is a right triangle, then a squared plus b squared will equal c squared. Remember that a and b are the two shorter sides connected to the 90-degree angle, and c would be the hypotenuse, or the longest side. In this case, we have 7 squared plus 24 squared, and we're going to check to see if that equals 25 squared. Remember that squaring a number means multiplying it to itself. So 7 squared equals 49, 24 squared equals 576, and 25 squared equals 625. Since 49 plus 576 equals 625, this is a right triangle, and angle A is a 90-degree angle. Let's see another example. In this case, we have a 90-degree angle on our triangle, meaning it is a right triangle. Therefore, a squared plus b squared must equal c squared, and we need to find the value of x, which is the length of one of the two legs of our right triangle. We're going to use the Pythagorean theorem, a squared plus b squared equals c squared, remembering that a and b are the two legs, and c would be the hypotenuse. In this case, we have x squared plus 15 squared equals 21 squared. In order to solve this equation, we must first simplify both sides by squaring 15 and squaring 21, then use our inverse operations to isolate the variable x. That means we'll get rid of the plus 225 by subtracting 225 from both sides of our equation, and we'll cancel out the squared by doing the opposite, which is a square root on both sides. The square root of 216 is a decimal, which is an irrational number, a decimal that keeps going forever. We use squiggly equal signs to represent that we are estimating this number. However, the instructions say to round this to the nearest hundredth, so we're going to go ahead and cut off the rest of the decimals. Since the first number that we're cutting off is 6, we're going to bump that to the 69 up into a 70 and have 14.70. Let's see one more example. We can find the distance between 2 points on the graph using the distance formula. All we have to do is draw a vertical and horizontal line coming down and over between those 2 points to create a 90-degree angle. This will become a right triangle together with the distance we're looking for. We can count squares to see the vertical and horizontal distance, or the two legs, A and B, of our right triangle, and c would represent the distance we're trying to find, or the hypotenuse of our right triangle. We use a squared plus b squared equals c squared, our Pythagorean theorem, plugging in the values 6 and 4.5 for a and b, and when we solve for c, that will be the distance between the 2 points we're looking for. We simplify both sides by squaring 6 and squaring 4.5, and then combining those two numbers together. 36 plus 20.25 is 56.25. Now we use our inverse operations, cancel out a squared using a square root, and the square root of 56.25 is exactly 7.5 units. That means the distance between our 2 points is 7.5 units.